Thank you for attending our virtual talk today. We'd like to especially thank InfluxDB for having us as a part of InfluxDB Web Summit 2019. Today we will be talking a little bit about our experience with data and data stores, specifically as it relates to relational versus time series databases, and kind of sharing some of our journey and our knowledge and our experiences as we've kind of expanded our horizons of different data stores for solving different kinds of problems. I am Jason Sewell. I am one of the co-founders of a company called Sudokrew, and this is...
Yeah, I'm Tony. I'm a lead developer at Sudokrew, so I help out on the application structure and really any suggestions to the DevOps people that need to set up our applications for us.
Yeah, and I guess I should say what I do as well. I'm kind of at this point more really doing DevOps, DevSecOps, architectural planning. So Tony and I work together a lot in terms of high-level, planning around the solutions that we're building, and having these kind of conversations about, hey, should we use the relational database? Should we use a time series database? And kind of talking about the pros and cons of each. So, and then really Tony is in charge for a lot of the implementation and kind of leading other developers. So that's kind of our relationship, our working relationship, and kind of what our responsibilities are. A little bit about us as a company and what we do specifically is Sudokrew is a consultancy. We are located in Honolulu, Hawaii. And being in Honolulu, we're one of the leading states in terms of renewable energy goals and getting to 100% renewable energy as a state mandate. And so with that, we have a lot of innovation in that space. We have Elemental Accelerator, who's one of the top startup accelerator companies in the nation for companies that are established, kind of trying to get to like Series A. So post-seed, I guess, is probably the best way to put it. So they're out here. We've worked a little bit with them. We work with some of the other clients you've seen in terms of Blue Planet Energy. We work with them in terms of doing batteries, solar battery storage, data storage analysis, that kind of stuff. Revolution is a solar manufacturer, so working a lot within solar prospecting and building out their smart home. Island Pulse and WeFishency were both with a local nonprofit called Blue Planet Foundation, and it's kind of looking at energy usage and consumption and in here in Hawaii. So all of these projects generally come with it energy data.
Yeah, a lot of data. I mean, like when we first started, we didn't always use like a time series database, especially for the smaller applications that weren't really chugging up too much data. But historical views, things like that, where you only have like maybe 12 points of data, we didn't really need a time series database. But then as we started to like work on larger projects, those ones started to aggregate data much faster than the other ones. So that's our experience working with them.
We build a lot of APIs, data engineering, custom solutions. We do a lot of JavaScript. That's for people who really don't like JavaScript. We're not scrapping JavaScript yet. Yeah, we're not ready to jump on the next train, but who knows? We do a lot of cloud infrastructure, so data pipelines and stuff like that. So that kind of leads us to what we've come to really find out that we like to do or love to do is working with energy data. And with that, we've had to make a lot of choices along the way, kind of as Tony mentioned, is how do we work with this data?
I mean, it's always fun too, because especially with like in the end, it comes down to like electricity for the most part, but I think there's a lot of nice ways to display that data. Our designers always have a lot of fun trying to convey needs to either the customers that are, the data affects them directly, or even like the businesses that need to make decisions that are going to keep their projects running, things like that. And So we have a lot of different use cases for the same kind of data, and everyone's kind of trying to pull their own, conclusions from that, whether or not they're going to make a decision that's going to affect, what they're going to eat today, is it's going to have like some sort of environmental effect, or if, we're not going to be able to run our business anymore. So especially nowadays, we're living in an informational age. We have things like YouTube and Twitter and Twitch. I don't know, like all these different platforms that are generating a ton of data. I don't really know the metrics on it, but I'm pretty sure there's something like 1 hour of YouTube data is like, I don't know, it's like more than terabytes, right? Like it's definitely more than what was being produced in like the 90s.
Yeah, I think there was a statistic out there I saw a couple of years ago is 90% of the data that is currently being stored has been generated since like 2015 or something like that. And so that's only a couple of years. So it's kind of what we're talking about. Then is the things that we're tracking with especially energy data. We're talking about telemetry as we're tracking many devices that are reporting by the millisecond, by the second, by the minute. We're kind of like you said, we're tracking mouse movements and how people are interacting with applications. So a couple of years ago, when we started getting into web development, not that long ago, it was all relational databases. That's what you did, and they were very good at what they do. But now with just this explosion of data, we have to start looking at some of these alternative data stores.
Yeah, like NoSQL versus SQL. Which one is the best? I think that's a really good segue into just knowing what kind of databases are out there. I mean, we're joking about SQL and NoSQL. You have Mongo, Redis, MySQL, Postgres is really big.
InfluxDB.
Influx, yeah. How could I forget that one? But I mean, in the end, it really depends, right, on what your application is going to be. You need to know what kind of data you need. Like sometimes it's just numbers when you're talking about registers and stuff like that, or is it a CMS where you want to have your blog posts and things like that, or is it like system logs where it's kind of a mix of those things. You have timestamps, you have aggregate values and stuff like that you want to actually be able to filter through, I guess. Things like tagging is really important too for like if you want to filter and query those logs. If you're ever going to need to change that data, then maybe you want to be able to have like a data store that lets you edit really easily, or maybe it's not important. So
yeah, and I think that was, it's something that we've learned over time is, kind of in the footer here is that, and the reason why we're doing this talk is that we're a consultancy. We work with a lot of companies that have prior technology, prior IP, prior solutions, and they're trying to get somewhere based on new technology or new direction of the business. And so a lot of times, what we've seen in our experience is that people default to what they know. And it's very hard to, make decisions about technology that you're not familiar with when you're on budget timelines and, just being comfortable with making those right decisions. So kind of these are some of the things that I think in retrospect, we wish we would have known, in the past of some of the right questions to ask up front to make better decisions, because most of what we know is not from making the right decisions every time, but having made wrong decisions and learning the consequences or the limitations of those. So that's really what we want to try to share, if anything, today.
Nice. Okay, well, got some little theory stuff here. There's like 3 categories or properties of data storage that are really important. I guess that one for us especially is it's between consistency, availability, and partition tolerance. This is also known as the CAP theorem, but what they say is that you can only have really only 2 of these things at any given time, because like if you're consistent and highly available, you're not going to be able to partition that across multiple like shards and stuff like that. But if you have like high availability and you want to have your data partitioned, you're probably not going to be consistent across all of those at any given time, because they need some sort of time where they are syncing up with each other. And the other side too is like, if you're always consistent and everything is partitioned, then there's going to be times where it might not be available, especially when you want to query that data and guarantee that that data is always going to be the same whenever you query it. So it might not be completely available at that time. And that's really what it means. So it's generally just pick two of these things, and you don't even need to be all of two at any given time. You can kind of spread that out. So a lot of systems actually swap between one of the two. Usually consistency and availability, and consistency and partition tolerance, or something along those lines.
I think kind of even as we're working towards is that, our systems are just getting more and more complex all the time. I mean, we're not really ever talking even about, a web server talking to a database. I mean, these our overall solutions versus kind of like the one data flow are much more complex than they were, several years ago. So
what would have been out there? Like maybe like Hadoop or Couch or something like that. I don't even know if that were big table. I don't know.
Yeah.
There's some.
I think even around 10 years ago, we were messing around with like even in-memory, like
Yeah,
I was working like in-memory XML databases just to solve some of those performance.
yeah, like Redis and stuff like that, right?
So it was pulling in data from a relational database, but trying to access it more quickly. It's very similar to Redis. But so what's a relational database good for?
I mean, I guess just if you have like lots of rows, transactions, definitely transactions. If your application needs to guarantee that when someone, I don't know, buys something or reserves something, that's not going to be taken by another one if like two requests come in at the same time, right? That would be bad if you sold 2 airplane tickets for the same seat or something along those lines. I think also just managing like a single state is kind of good if you're thinking about everything as like a collection of all of those things.
Yeah, I think that's a really good point, especially for this talk, is that, especially as, working with energy data, which is essentially telemetry data, is that we're not just worried about the current state of, of a device, right? It's not a wallet, like what's your current balance? It's, really we're looking at it for analytics, we're looking for trends. We have, sometimes this data goes into, warranties, how has a device performed over time. So really, a relational database really represents the current state of something well, but it doesn't represent that historical state well, yeah.
Right. I mean, even then, like when you're doing like, when you're backing up your databases, I think that's always like the fear that I have whenever, if you're running a big database and it's like if something terrible happened, right? Like it's like what can you do? You can like roll back to your previous snapshot, right?
Right.
But you don't really know like what happened between that snapshot and today.
Yeah.
And that's always like, well, I guess we gotta take like a lot of snapshots really quickly, or
even if it's just seconds, right? Like, I mean, if you're, a couple seconds to swap over what's happening in that time, it's very hard.
Right. And I think that makes sense then, like for time series databases, which is like almost the complete opposite of that. I mean, yes, you can kind of like, I guess you could like reduce like all the data points down, but in the end, it's going to you're still going to have like a trail, I guess, for each of these data series. Something that's going to, if you're monitoring like 50 devices, I don't really care too much about like what the device's current value is. I really care more about like how that data has been changing over time. Because in a lot of cases, especially if you're doing it like by second, as soon as you get that one, like the current data, that's instantly just going to be like obsolete, right? Like it's just going to be replaced. So I think in a lot of, like, especially with energy data, you're really looking for things like spikes in data, or data just like completely going out at the same time and knowing when there's outages. I think those are more important, but it's all like kind of relative to the other points in that time series.
Right. Yeah, and I think one of the things I really enjoy working with time series database, for at least from like an architectural or an engineering point of view, is just kind of like we talked about. If we lose, a couple of data points, it doesn't matter, and it really, it's a very kind of small moment in time, and a lot of times that's not all that important to the big picture. When you're looking at a trend of 5-year data, it doesn't really matter if you lost a couple minutes here and there. Something that we do with time series and Influx is really good at is aggregating that data. Sometimes we care about the minute view and we need 60 seconds, but a year out, generally in real-time reporting, we need to know what's happened for the last 5 minutes. A year down the road, we just need to know what happened that hour or that, or that day. And so we have the ability to really kind of aggregate that data over time, and that helps with data storage, cost, and performance and things like that as data gets a little bit older and isn't so critical to have that super granular view.
I mean, I think that's a really good point too, is just like bringing up like querying that data, because I mean, I feel like before I used an actual time series database, I never, like, it felt like I always had to like write my own queries versus like I'm very comfortable writing SQL and, like select the count or select, I don't even know, but like if I wanted to do something like an average of something like that, something that instantly has to go into like my application code, I'm like, oh, I hope I don't, mess this up or something like that. So, I mean, I think that that's another good thing about it, is that like a lot of good time series databases provide a way to do that. They provide a way to run, like, I don't know, moving averages or something that is over time, I guess, like being able to find where there was like a jump in your data, like where there's disturbance. I don't know exactly how to word that one, but which would be really difficult to do with like a SQL one, because you're just like going to pull down like, I don't know, like a million data points, and do you just filter out the ones where it's plus or minus 20 or something? I don't know, from the one right next to it. Like, I don't know.
How many joins can you do on a table of this? How many joins can you do on the same table, right?
Yeah.
Kind of another one of those kind of things where sometimes you need to answer that, and that's very hard to do in that model. So which one should we use, Tony? Which one is it? Is it time series or is it relational? I want to know the answer.
I definitely think time series is the way to go. I really think it depends. It really does, because like even in all of our applications, we are never bound like specifically to one data store, because we definitely will pick whatever works for our data. If we're managing multiple devices, we're storing that in a CMS, but we're not storing the data for those devices in the same place where we're keeping track of like who's registered to which owner and stuff like that.
Right. And kind of the world that we live in is that we're not building a single 3-tier application anymore. We're building large systems. We have lots of different stakeholders within those systems. We have lots of different kinds of data. And so ultimately, yeah, the question, or I should say the answer to that question for us usually boils down to it's not an either or scenario. It's a combination of both. And it's leveraging technologies that were both built to be really good at what they do specifically. And as we build these larger systems and kind of answer some of those questions up front, and realize what the strengths and weaknesses of each are, it really complements our it creates our happy data family, right? We're not making choices of who's our favorite child. It's that we have multiple, and we love them all for their strengths and weaknesses.
Yeah, strengths and weaknesses, definitely.
But this is kind of a very, very simple diagram of really where we're at today is that we have a lot of IoT devices deployed in the field. They're all monitoring, you know, things at a very granular level, like I said, second or millisecond, different kinds of data, whether it's, you know, humidity, you know, state of charge, all kinds of different things, and they come into our you know our endpoints, and we create multiple paths. And so, you know, a data scientist who's going to be doing trend analysis and predictive you know, predictive analysis kind of stuff, they're going to want to see some of that time series, you know, that time series views and be able to play with the data, and we can do that really, really well with something like InfluxDB. And then we're going to have people that are, you know, we kind of have a systems engineer here who's just more worried about the consistency of data, and are all the devices in the field being tracked, that we know which devices are at which facility, and we know which sensors are part of which devices, and that's, again, it's what the relational database can do.
I think some other things too, like on the application performance side of it, you know, like it was a lot easier for us to throw that into Influx. Like if you have, you know, a couple 100,000 devices all pushing data like live every minute, every second, you know, that's a lot of writes that are happening, which I don't know how well that would perform if we were storing it in like a SQL database. Versus like when we have like administrators and people that are reassigning those devices, you know, that's very infrequent. And that's also the part that's facing the client more often, like a human that's looking at it versus, you know, I guess another side would be like, I guess the end user too. But like sometimes you don't need to see like all that data every second constantly, right? Like as a person, you can only really see like so much at any given time. So you'd be overwhelmed by all of that. And so I think that there's some, that's some good stuff about the time series database. It's just being able to handle that throughput at the machine level. And I guess we're able to also be kind of like flexible on the system side to be able to handle that. It's not just Influx either. Like I think our diagram doesn't even have things like all of our message queues that need to consume all of this data. But I think like the great thing about it is it's been really flexible.
Yeah, so I think we're about up on time. So that is kind of a bit about us and our discovery of, you know, kind of where we've been working with time series and energy data. This is what we love to do. We love energy data apps. We love working with big data and talking about all kinds of data stores. If that's something that's of interest to you and you want to know more about, you know, potential solutions or, you know, things, or you're trying to solve similar problems, please come talk to us. You can reach us at hello@sudokrew.com. We also have a virtual booth running for the InfluxDB Web Summit. So come check us out, come reach out to us. We're happy to nerd out and talk to you about data all day long. So you can find us on Twitter, Tony or Jason, or you can reach out to us at hello@sudokrew.com. And again, just want to thank InfluxDB for having us be a part of Web Summit 2019, and we look forward to talking to you very soon. Aloha.
Bye.
Bye.